bring it to the folks. Snoop Doggy Dogg and Dr. Dre is at the door, ready to make an entrance, so back on up.
Welcome to second semester as we begin the new material for this course with what are called wrapping functions. W-R-A-P-P-I-N-G, wrapping functions, okay? Before I discuss wrapping functions, first want to go into, or to remind you, general concepts about functions you've dealt with before wrapping functions, because wrapping functions are brand new. You've probably never seen them before in your life. The kinds of functions you've had experience with before are like this. Okay, previously, we've had an input, which generally was the x variable, okay, and then an output, which was y. Okay, so you enter a value for x, and that's your input, and then you get a value for y, and that's your output. That's usually the answer, okay? The notation we've used is up here. F of x equals 3x squared minus 6x plus 2. So if we wanted to input a value of negative 2 for x, the input's negative 2, we would then just input that value, enter that value in for x, and what we would get is, well, negative 2 squared is 4, times 3 is 12, negative 6 times negative 2 is also positive 12, so 12 plus 2. The output would therefore be 26, okay? So if we input an x value of negative 2, our output is 26. X is a number, y is a number. The input is a number, the output is a number, okay? That's usually how functions work, okay? With wrapping functions, you've got to kind of wrap your mind around something brand new, okay? The input is no longer just a number, okay? Well, it is a number, but it's not just any old arbitrary number, okay? It specifically means the length of a wrap, okay? What a wrap is generally we deal with wrapping functions as circles, okay? So when you have a circle drawn here, our starting point will always be 1, 0, okay? This is what's called the unit circle. It's a circle of radius 1, hence the name unit circle, 1 unit. So we're always starting at the point 1, 0, all right? That's on the initial side, 1, 0. And then if we're talking about the length of a wrap, we're talking about the length of distance, or the distance we've come from this point around the circle. So it's all about circumference. The circumference of a unit circle, well, circumference is 2 pi r. The circumference of a circle is 2 pi r. So if the radius is 1 of the unit circle, then the circumference is exactly 2 pi. I'll jot that down here. The circumference of this circle is 2 pi, okay? So if we go all the way around, okay, if we talk about a wrap of exactly 2 pi the whole way around, well, that's our input, the 2 pi. And the output would just be that point, 1, 0. Let's jot this down, just so I kind of have an organized way of explaining this to you. Because it's a new concept, it's very kind of challenging to really focus and to understand this stuff. So let me write this down. W of 2 pi, that would indicate from this point wrapping all around the full 2 pi, okay? Because the whole circumference is 2 pi, so if we wanted to wrap all around 2 pi times, we would get back to that original point. That original point, the coordinates of that point, is the new output, okay? So whereas the input is the length of the wrap, essentially the length of the circumference you're going around. In this case, I have a problem W of 2 pi. The output, the answer, is an ordered pair, and in this case, we're back to the original spot. We go all the way around. So a wrap of 2 pi is 1, 0. Well, what about a wrap of just plain old pi? If you think about it, guys, pi would be half the circumference, right? So if we started here, and then we went a wrap of only pi, well, the whole thing was 2 pi, so pi would just get us right there, halfway around the circle. So what are the coordinates at that point? Well, negative 1, 0, right? Again, this is a unit circle, so you can assume the radius is exactly 1. Okay, so at that point, the distance from any point on the circle to the origin, to the center, is 1. So this point is negative 1, 0. So that's how we would indicate that, all right? Now we can get a little bit more aggressive. It doesn't always have to be multiples of pi that we enter in. Maybe you'll see pi over 2, or 5 pi over 6. Okay, and I'll explain why those weird fractions kind of work out well. All right. Now, one comment I want to make before I go on is a wrapping function is what's called a type of a periodic function. If you think about it, if we go around, once we get past 2 pi, we're just going to repeat after that those ordered pairs. So, w of 2 pi is 1, 0, while w of 4 pi is also 1, 0. W of 6 pi is also 1, 0. So w of any even number of pi's is going to be 1, 0. W of any odd number of pi's is negative 1, 0. You can go backwards also. Okay, that's what's getting a little confusing now, but these are all positive wraps, right? Positive means we're going counterclockwise. Okay, counterclockwise is a positive wrap. To go clockwise, we have a negative wrap. Okay, so we'll get to that in a little while. Let's get a little bit more challenging though before we get into the negative wraps. All right, because yeah, the domain of this, the types of wraps you can enter here, or the lengths of wraps you can enter here, is a set of all real numbers. You can enter negative wraps. You can have a wrap of 0. A wrap of 0, you'd be at 1, 0. You haven't gone anywhere. You can have a very, very large wrap also in the positives. Okay, there's no restriction on the domain for a wrapping function. Okay, let's input though something like this. What about pi over 2? I hope this isn't too unorganized, this kind of overlapping here, but we'll see where we can go with this. So I don't have to re-record, okay? But a wrap of pi over 2. Well, think about where that might end up, right? The way we got the wrap of pi was just by cutting a wrap of 2 pi right in half. Right? The wrap of 2 pi was all the way around. A wrap of pi is halfway around. So a wrap of a half pi, or pi over 2, is 1/4 of the way around the circle. Okay? A wrap of pi over 2 would get us right there. And the coordinates are at 0, 1. Right? So the wrap of pi over 2 is at 0, 1. Okay? And what I've written here on the board, I don't know if you can see it. I believe you can. Okay? This is what I originally had up here. If we have an input 3 pi over 2, you would see that written as this, right? W of 3 pi over 2. Okay? Just like these. So if we're wondering where 3 pi over 2 would end up, well, you can think about it one of several ways. Okay? It's like 1½ pi. So we have 3 pi over 2 would be, here's 1 pi. And remember, 1/2 pi is a quarter of the way around. So we go a full pi and then another quarter of a pi, and we're down there. It might even be easier for you to consider 3 pi over 2 as, well, it's just pi over 2 times 3, right? So if we're talking about a wrap of 3 pi over 2, it's like 1 pi over 2 3 times. 1 pi over 2 got us here. Well, that would be 2 pi over 2, which is just pi. 3 pi over 2, 4 pi over 2 would be 2 pi, etc. Okay? It's kind of a nice idea to break up all the wraps in terms of pi over 2. Again, 1 pi over 2, 2 pi over 2 is just pi. 3 pi over 2, 4 pi over 2 would be 2 pi. Always try to reduce those fractions. That'll help you in the long run. You'll hopefully see why that is later. Okay? So we've just kind of derived the very basic first 4 wraps. Okay? Let me actually erase this and write the last one down here so you have it all organized. These are the first 4 of, that would be 0, -1 down there, right? Yeah, that would be a wrap of 3 pi over 2 would be at 0, -1. Okay? So again, these are the most 4 basic ones. We get much more aggressive soon, but you'll see this is the beginning of trigonometry.